All right, I'm going to go through many examples of problems that you may need a refresher on. It is up to you how many notes you take, what type of notes you take, how much you write down. If you want to skip a section because you're comfortable, I think that's great. Feel free to stop the video at any time. I suggest if you have questions or don't understand something that you use a post-it note out to the side of your note or somehow make yourself a little special note so that you can talk to me about this in class. All right, some things to get our brain going here. I've got 3 questions. What does it mean to simplify? What does it mean to rationalize the denominator? And what is the difference between solve and evaluate? I'm going to actually connect the first and the last questions. What does it mean to simplify? And what is the difference between solve and evaluate? Simplify can mean actually several things. It could mean get rid of the parentheses. It could mean reduce and cancel terms. You're not actually solving for anything. Nothing equals anything. When you simplify something, you're stating it in a different form. When you're actually solving for something, you're figuring out an answer, a solution. You're finding out what X means. Oftentimes, they may use the word simplify or evaluate. To me, evaluate means just do it. So for example, if I see 2 plus 3, just plain old, 2 plus 3. It might say evaluate, meaning just do it. 2 plus 3 is 5. You're not solving for X or anything. A solve question will have an equal sign somewhere in the equation. It's kind of the difference between equation and expression. Expression does not have an equal sign, equation does. All right, so what does it mean to rationalize the denominator? That means get radicals out of the denominator. For some reason, it's bad form to have radicals in the denominator. I didn't make up this rule. It is the way it is. And so if the directions say that, you need to get rid of the radical in the denominator. The great thing about this course is that oftentimes we won't simplify. If the problem is a free response question, meaning not a multiple choice, you do not have to simplify, meaning you can leave it as the square root of 25. You can leave it as 5/10. You can leave it as 5 plus 7. You don't have to simplify and combine like terms. We do so many multiple choice questions, though, that we're still going to practice simplifying because the multiple choice selections, our 4 or 5 choices that we have, will be simplified. All right. What do you remember about factoring? When I teach factoring in Algebra 2 is probably where you learned it, maybe some in Algebra 1, I have a step process that I use. The first thing that I always do when I factor, always, no matter what I'm factoring, if it's got trig functions or x's or numbers, is I look for a common factor. What do all of the terms have in common? Another choice that we have is to factor by grouping. Factor by grouping you use when there's 4 or more terms. So look for a common factor you can use if there's anywhere from 2 to 10 terms. Factor by grouping you're going to use when there's 4 or more terms, and I'll do an example with you here in a second. Difference of perfect squares. That's when you have something like a perfect square like x squared, and then you have another perfect square like 25 or 49, or maybe I have a squared. And when you factor these, you have 2 binomials, one with a plus and one with a minus. What happens with the difference perfect squares is that your middle term is missing, and so in your factors with 1 plus and 1 minus, when you were to distribute those all out, they would cancel each other. Perfect square trinomials, those are ones that look like this. X squared, and then you have another squared at the end, and then in the middle there's 2 of these, something like this. And we'll do some examples like that. One might be x squared minus 10x plus 25. This ends up being x minus 5 quantity squared. So you can see why it's a perfect square. It's perfect, but yet it's a trinomial, meaning it has 3 terms here. 1, 2, 3. The 2 comes because the outside and the inside terms, when you distribute, are the same. The AC method, that's one that you'll definitely need to know for problems on any of your assignments or tests. The sum and difference of perfect cubes, this may be one you've forgotten. I'll put the formula up here in a minute. So a cube, instead of being a square, we have a cube. So it's a cubed and b cubed, and there could be a plus or a minus in between there. All right. What does factoring do for us? Like, what's the point of factoring? What factoring does for us is it helps us to find the zeros, roots, x-intercepts, solutions. That's what it does for us. Factoring breaks it down to where that polynomial or quadratic came from. So let's do some examples together. The first one says factor completely. All right, if you're taking notes, you might look back and say, okay, what was the first step in factoring? And the first step in factoring was to look for a common factor. Each one of these terms has a 2 in it, so I'm going to take that out. And when I do so, I now have this. I have 2 times the quantity x to the 4th minus x squared minus 20. Now I can keep factoring. This is a trinomial. And remember that how we factor trinomials is we look to see what multiplies to be the last term, what multiplies to be negative 20, but what adds to be 1. Well, what does multiply to be 20 and add to be 1? Negative 5 and positive 4. So what's going to go here is a negative 5. Oops, having trouble with my... Obviously having all sorts of trouble here. Let's try clicking this. Here we go. So what multiplies to be negative 20 is negative 5 and a positive 4. Now if I put x's here, x times x, this x times this x is not going to give me x to the 4th. So what this has to be here is that it has to be a squared. Now if I think about this, let's think about foiling it or distributing this, and will I get what I started with? X squared times x squared is x to the 4th. Good. X squared times 4 is 4x squared. Negative 5 times x squared is negative 5x squared. If I combine those like terms and simplify, I will have negative 1x squared, and then last is negative 5 and a positive 4, 20. I can't go any further because this isn't a perfect square. If that was an x squared minus 9 or an x squared minus 4, I could continue factoring it, but I can't. I can't factor this anymore because it's a plus 4. All right, so there's one example of factoring. All right, the next one. You notice how this one has 4 terms. So I'm going to remind you how to factor by group. 1, 2, 3, 4 terms. So what I'm going to do is I'm going to group the first 2 terms and the second 2 terms. Whatever sign is in my 2 groups, I bring down. So I've already taken a minus, a negative out. What do these 2 have in common? They both have an x squared. When I take it out, I get an x minus 4. All right, what do these 2 have in common? Yeah, they both have a 25. But you notice how because I have this negative here, I actually factored out a negative 25. So this becomes a positive x, and this becomes a negative 4. Think about it. Negative 25 times negative 4 would end up being positive 100. Now look, see how they both have an x minus 4? When you factor by grouping, those have to be the same. If they're not, you've either done something wrong or this problem won't factor by grouping. So let's go ahead and finish. I'm going to take the x minus 4 out front. Just like right here, I took the x squared out. I'm taking this x minus 4, I'm taking it out front, and what would be left here is an x squared, and what would be left here is a minus 25. This one I can go one more step. X squared minus 25, that's the difference of perfect squares. I have x plus 5, x minus 5. Next one. All right, this is the cube one. I'm going to write this formula up on the board here. You need to have this memorized. If I want to factor 2 terms, excuse me, that are cubed, it ends up being like this. Excuse me, if this is a minus, this becomes a minus. How do I remember this? I am not a great memorizer, so I either come up with a little song or something, or I have it make sense. This makes sense to me because this totally makes sense. A minus B, A minus B. A plus B, A plus B. That just makes sense. Well, what do I have to take this A times to get an A cubed, an A squared? See how there's squares on the beginning and the end? This has a square and this has a square. A squared times A is A cubed. B squared times B is B cubed. So what's this middle stuff then? Why do I need this in the middle? Well, that way when I distribute everything out, everything else has to cancel because I only want the A cubed and the B cubed. You notice how these 2 signs are different. This is a minus and this is a plus. This is a plus and this is a minus. All right, so that's the formula. So when I go to factor this, what am I going to do? Well, both of these are perfect. They're perfectly cubed. So this is 5x cubed. 5 cubed is 125, x cubed is x cubed. This is 2 cubed. And so what I have here is 5x plus 2y. Do you see where I got those? 5x cubed and then the quantity 2y cubed. So what needs to come here in this next one? Squares. I'm going to start with squares. 5x squared is 25x squared. 2y squared is 4y squared. Squares are always positive. Since this is a plus, this is going to be a minus, and I multiply these two together, so I get 10xy. All right, there's an example of one of those. Next one, I'm going to have to use AC method. How do I know when I have to use AC method? I use AC method when it's a trinomial, meaning 3 terms, and when the leading term is not 1. You notice how up here on this first problem right here, I didn't use the AC method. I just looked to see what multiplied to be 20 and added to be -1. Here, I do need to use the AC method because this 7 is here. So this is A, this is B, and this is C. AC is 7 times 2, which is 14. What multiplies to be 14 and adds to be -15? -14, -1. Those will multiply together to be A times C, and then add together to be B. Now the thing is, I can't do this. I can't just do this. Doesn't work. Think about foiling or distributing that on out. Am I going to get a 7x squared? Where's that going to come from? No, this is wrong. So with the AC method, I'm going to come over here. What you have to do is you have to separate your middle term into the ones that I've just circled. So I'm going to rewrite 7x squared. Instead of writing -15x, I'm going to write -14x minus 1x. It's fair. -14x minus 1x is -15x. It doesn't matter what order you put them in. And now plus 2. So I just rewrote it. This over here is the same as what I rewrote. And now I go forward with factor by grouping because there's 4 terms. So I look to see what these guys have in common. I write then a negative there. Oh, these guys don't have anything in common. And so when they don't have anything in common, I like to write a 1 there because everything always has a 1 in common. And this is going to become a -2 because I factored out that negative. And then my last step. That is the AC method. And now you know when to use it. Next one, 50 minus 2m to the 6th. All right, what was the first step in factoring again? Yep, look for a common factor. So what do these guys both have? They're both even. I can take out a 2. All right, now what do they both have? Is this a difference of perfect squares? 25 is a perfect square. But m to the 6th, well, it's a perfect square too. What do you have to square to get m to the 6th? You have to square m cubed. You might think of these as the difference of perfect cubes. M to the 6th is also a perfect cube, but 25 is not. So this is the difference of perfect squares. So I'm going to leave my 2 hanging out. That means I have 1 plus, 1 minus. What do I square to get 25? 5. And what do I square to get m to the 6th? I would square m cubed. Now, is 5 a perfect cube? Nope, so I can't go any further. There's a quick review of factoring. All right, what is domain? Domain is numbers that you can plug in. They're x values. It's the input. It's the independent variable. What can change your domain are things like a radical, because you can't take the square root of a negative number. You can't take the square root of a negative number. So if you have a radical, an even-rooted radical, you can't plug a negative number into that. So that restricts your domain. If you have an x in the denominator, that might also restrict your domain because you can't have 0 in the denominator. The things that restrict our domain are even-rooted radicals, denominators, piecewise functions, which we'll talk about, and then just any given information. What is range? Range is y values. It's the output. It's what you get when you stick in your x or your independent variable. Range depends on x. It's the y values. What are the steps for finding the domain? All right, I talked to you a little bit about that. You want to look on, for even-rooted radicals. They have to be, whatever's under the radical has to be greater than or equal to 0. And then you want to look for denominators. Denominators. I didn't write that right, but denominators cannot equal 0. All right, so just a little heads up. I have the feeling that you're going to have more questions about domain and range, and you're going to need to ask me about that in class. So if you're choosing to do certain problems at the beginning from your worksheet, what we talked about today, I would suggest these specific problems just based on what we've went over today. I'm going to keep going, however. All right. Properties of exponents. I'm going to write up these answers. This is stuff you should already know. If you've forgotten, you need to unforget it. Here, you add the exponents. Here, divide, multiply. This is just reminding that if you have two things in parentheses, the exponent goes with both of the factors in there. Same thing for dividing. Negative, I don't know if you can see that very well. A negative exponent moves it to the denominator. Anytime the term moves from the numerator to denominator or denominator to numerator, the sign of the exponent changes. So what if I have a fraction then? Well, if I flip both of them over, you notice how the A went to the bottom and the B went to the top. Now they're both a positive n. Anything to the 0 power is 1. And here, how do I handle something that is a fraction power? I rewrite it like this. This is stuff that you really do already know. I know I'm going through it fast. Some of this you probably remember very well, and some of it you're like, whoa, I never learned that before, which is totally not true. But you've forgotten. So let's do a couple examples here. The directions here would probably say simplify, because there's no equal sign. We're just kind of writing it in a better form. So the first one, what I'm going to do is take care of the numerator first. I'm going to leave the denominator. I need to cube everything inside the parentheses. So I'm going to cube my 5, and I'm going to cube my x squared. Now I'm going to combine my like terms. 5 cubed is 125, and 3 is 3. I can't simplify those. It's not possible. But I can go ahead and put my x's together. In the top, I have an x to the 6th, and the bottom, I have an x. So when I put those together, I have an x to the 5th, and then this y is still hanging out. That's as far as that'll go. Next one. I'm going to leave the 10 alone. I don't know what to do with any of this yet, but I'm going to try to simplify this bottom. The square root of 25 is 5. How can I write the square root of a to the 4th? I can write that as a to the 4 halves, because there's an invisible 2 there, right? So a to the 4 halves is a to the 2. So then how can I do the same thing with b? How can I rewrite this? This would become b to the 1 half. So I'm going to write b to the 1 half here. Now I've got everything out of the parentheses or out of the radical, so I'm going to combine my terms. 10/5 is 2. A to the 7th over a to the squared, I subtract the exponents, and it's 5. And when I do b to the 3 halves over b to the 1 half, 3 half minus 1 half is squared. That one's done. Last one. Oh, goodness, negative exponents. I'm going to leave this alone for now. I'm going to deal with this parenthesis at the bottom. Power to power, I multiply. So I have m to the negative 3rd, n to the, ooh, that's nice, positive 2. Now, what the heck? When I have m to the negative 5th over m to the negative 3rd, I'm going to think of that as negative 5 minus negative 3. So that becomes a plus. This then becomes m to the negative 2, and I have n to the 4th. But the directions say write with positive rational exponents only, so I want to move this m to the bottom. Okay. Is it coming back to you? I hope so. Okay, woo, we are flying. Properties of logs. You learned logs in probably Advanced Algebra 2, and if not, you did them again in pre-calculus, or maybe there's a handful of you that are coming from analysis. So I'm going to plop these up on the board real quick, and then we'll do some examples. When you have two things that are multiplied together, you can separate those with addition. That means that division, division, you can do a subtraction. Now, if you want me to prove these to you, we can do that in class, but this should be a review, so I'm just reminding you. Here, this p that's right here can go out in front, so I can write this as log base a of m, and instead of writing the p up here, I can write it out in front. This is a change of base formula, which honestly, you guys really don't need to know anymore as long as you have the newer software operating system on your graphing calculator. So this is change of base, and most of you, I would like to show you, or check out your calculator. Most of you can do this automatically on your calculator, so you probably don't need that one. And then the last one, these two bases are the same. See how the two b's are the same? So this becomes just x. When these two bases are the same, and I can prove this to you too, so that if you don't understand why, and remember this from pre-calc or whenever you learned it, they cancel each other and it's just x. If you have ln of x, remember that that's really log base e of x. We just don't write it. And if there's not a log written there, it's really log base 10 of x. Okay, or don't forget about those. And then how do you go back and forth from log to exponent, exponent to log? I'm going to use my initials. My initials are S, K, N. So I'm telling you that S to the K power equals N. I know, it's like Dr. Seuss math. So I can write that as a log. Okay, I can write S to the K equals N as a log. My base is S. So it's log base S. Logs help us solve for exponents. So the exponent over here is what the log equals, and then the other number goes here. These two really mean the same thing. It's like speaking a different language. Exponent language, it's S to the K equals N. Log language, it's log base S to the N equals K. Those two mean the same thing. So let's do a couple examples. First one. I'm going to put these two together. They're inside the brackets. They have the same base, it's log base E, and there's a plus sign there. So since there's a plus sign there, can't I combine these by multiplying them? When I take x plus 2 times x minus 2, I get x squared minus 4. So I put those two together. Now this guy's still out here. Now what I'm going to do is I'm going to take this 4, I'm going to move it up here as a power. So I'm using, which property? That one right there. And so now I have ln of x minus ln of x squared minus 4 to the 4th, which now that that's a minus, I can put them together with division. So I have I have all of this, x divided by x squared minus 4 to the 4th. Sorry, that's hard to read. The next one, let's see. I really have a choice here. I could move this 2 over here and put it up here, or I could distribute my 1/2. There's not really a right or wrong. I think what I'm going to do is I'm going to go ahead and distribute the 1/2. So when I distribute the 1/2, I get 1/2 log base 4 of x plus 1 plus 1, because 1/2 times 2 is 1, log base 4 of x minus 1, minus, I'm going to go ahead and move that 6 over. See how I'm moving it over? And while I'm at it, I'm going to take this 1/2 and I'm going to move it over also. Okay? Let's see. How would I put these two together? It's a plus sign. So I'm going to put them together by multiplying. So I have log base 4 of. Instead of writing x plus 1 to the 1/2, I'm going to write it as the square root of x plus 1. And then since I'm multiplying, I also have x minus 1 there. And now this is a minus. So with minus, don't I divide? So I could take this divided by x to the 6. So I'm going to write that a little better because I kind of ran out of room. I have log base 4 of this big, huge mess. X minus 1, square root of x plus 1, all over x to the 6th. I don't think I can simplify that. I know it looks nasty, but that's as far as I can go. All right, next one. What is ln of e to the squared? Isn't that the same as log base e of e squared? What happens when these two are the same? They kind of cancel each other out. So this just becomes 2 plus 5, which is 7. All right, here. I'm really wondering what this is. What is it? I'm going to rewrite this log as an exponent. 5 to the sum power equals 1 over 125. Didn't we talk about 5 cubed is 125? So how do I get the 125 on the bottom? I write it as 5 to the negative 3. So this answer, instead of writing question mark, I now know that it's negative 3. Woo! There is a radically fast review of logs. All right, what do you remember about inverses? For an inverse, you exchange the x and y and solve for y. You exchange the x and y and solve for y. That's how I find an inverse. How do I graph an inverse? Well, I kind of like to graph it the same. A graph of the inverse is a reflection about the line y equals x. It's like a reflection. However, sometimes what I do is I just exchange all of the x and y values and then regraph it. So I'll do a couple with you here. This first one is just graphing it. So here's how I'm going to graph this inverse. Every point I have, I'm going to take and I'm going to flip the x and the y. So this point right here, my board is not very calibrated, so I'm going to try. Oh, I'm way off. Let me try again. Yep. So this point right here, 1, -2. When I exchange the x and y, that becomes -2, 1. And -2, 1 would be right about there. So I just moved that point. Let's take another point and move it. Let's take the point 3, 2. What does it become? 2, 3. So that goes right up there. So see, the blue and the green are connected. So I'm going to connect those. So that line became this line. Okay, let's keep going here. Let's do the point 0, 1. What will it become? 1, 0. That's right. So that point goes there. So now these are connected. And then the last one, it's the point, let's see, I'm running out of colors. It's the point, I'll have to do blue again. -1, 0, so that becomes 0, -1. So that's right here. This point goes here. So now I'm going to go that guy, and it continues to, oops, I used the wrong color. It continues to go forever, doesn't it? It just keeps going and going. So that is okay. It's an okay. What you might note, if you can tell, is that the graphs are always a reflection across the line y equals x. So does it look like my dashed lines are a reflection a little bit? It's not perfect because I'm not perfect. Finding the inverses algebraically is a little bit easier. So I'm going to look at this first one. This says y equals the square root of 2x plus 5. That's what it says. F of x is really y. It's function notation. So what I'm going to do to find the inverse is I'm going to go up here and I'm going to switch the x and the y. So now it becomes x equals the square root of 2y plus 5. That's what the inverse does. It exchanges the x and y, the domain and the range, the input and the output. Now my job is to get y by itself. So what I'm going to do to get y by itself is I'm going to square both sides to get rid of the radical. That's how I get rid of radicals, is I square them. And now I'm going to subtract the 5 and divide by 2. So that's a little sloppy. I'll write the answer better down here. How we note inverses is we write them like this. Okay, so if f of x is equal to the square root of 2x plus 5, f's inverse, f inverse of x, which is written like that, is written x squared minus 5 all over 2. Okay? I'll do one more with you. This one's a little harder. Not too bad, though. I exchange my x and y. Now I have to solve for y, but the thing that's a little bit hard about this problem is I have 2 y's in my equation, don't I? I have a y here and I have a y there. So what I'm going to do first is, this fraction's kind of ticking me off, so I'm going to multiply both sides by y minus 4. I'm going to multiply both sides, that's fair, and distribute here. And now I'm like, oh, I got to get that y all by itself, but I have 2 y's. Well, let's at least get them on the same side. See how I got rid of that x? I just moved things around. And now this is the step that might be the hardest for you, is I'm going to factor out a y. And when I do, it becomes x minus 2. And now, voila, I can solve for y now. It becomes 4x over x minus 2. And how is it that I told you to write these if they're inverses? I told you to write them as f inverse of x. That's how you find the inverses. So, if you want to do a couple more problems, let me just see if I can get this a little bit better. You can try 3 through 6 and 22 and 23. And any other ones that you want to try, those are just the ones that we've covered a bit of. So I'm going to stop this recording right now, and if you're ready to go on and want some help on the next one, you just grab the next video and play it.